This is part 3 of our electron energy notes, and this little last section is to add on information about light emission and how electrons have to do with the colors of light that we see and how that comes to occur. So when we're talking about light emission, think about like the flame of a fire, or even if we were to like plug in, like neon lights, they reflect a certain color. And that has to do with their electrons being excited and then coming back to their ground state, releasing that energy. So excited state electrons are electrons that absorb energy from either electricity or heat source, and then eventually they have to return to ground state, and when they do, they release that energy. So let's write this down. Excited state electrons are electrons that absorb energy from heat or electricity, and then they must eventually return to ground state. Whatever goes up must come down. It's that idea. So that energy that's going in has to be released. And so when the light is released from an excited state electron, it's released as light. Okay? So the energy released as electrons return to lower energy levels. They're moving towards the nucleus, back towards lower energy levels. Then they release light. And this is the light emission that we see. The amount of energy that's released when an electron changes its energy levels is called a photon of energy. And when that electron returns to a ground state, it shines a specific color of light related to the distance it has traveled. And the light will have, if it's really energetic, a long energy release, then it'll be maybe purple or violet or blue. If it's a low energy change, then it might give off red or orange, like some of those lower level energy colors. So our visible spectrum of light has increasing energy, let's say this way. And if you think about Roy G. Biv, red, orange, yellow, green, we'll call it blue, and violet. There's our increasing energy. Higher energy is violet light, lower energy is red light. And each element has its own fingerprint of colors it will emit linked to its energy level transitions. And that different color is characteristic of the particular element. So we could say it's an intensive property. It would help us to identify an unknown. And that's actually what we're going to do in lab this week when we look at the flame test. But energy is released, giving off light. And that light has to do with the energy linked to it. So based on its energy, we'll have different colors of light. Okay? So let's take a look. I want you to flip to page 6, I believe, on your worksheet here. And based on what we just talked about, I want you to think through, I'm only going to do a few of these, but it should help you get to complete the rest. Emission occurs when electrons lose energy, and absorption occurs when electrons gain energy. So the first section is true or false, and if it's false, rewrite it so that it's true. An excited state electron has absorbed energy. True. Electrons can be excited by electricity. Oh, true. I'm doing all the trues, I guess. Fireworks emit light because their electrons are releasing energy. When we release energy, we get light. That is true. That's how fireworks show their color. So B and C, let's just go ahead and do them all together. When electrons return to ground state, they fall into the nucleus. That is false. Rather, they move toward the nucleus. They don't fall into it. A ground state electron emits light when it gains energy. That's also false. It emits light when it loses energy, because energy lost is the light itself as a photon. The second, you're identifying emission or absorption for each one. I'm just going to do a couple of these for real this time. So emission, again, that's when we're losing energy. Absorption is when we're getting more. So I'm going to do these pictures. So C, we have an arrow going to a higher energy source, and we've got a little plug-in. This looks like absorption. We're adding energy in by electricity. And this other picture here, the electron is moving towards the nucleus, going from high energy to low energy and showing light. That is emission. So that should help you do emission and absorption for each of these. And then number 3, using the visible light spectrum, we got them in order of increasing energy, red to violet. If each of the following emit visible light, match the color with their energy level transitions. So we have different changes in energy released. If we're going from a larger gap, then it's going to be more energy. So 6 to 1 is going to be more energy released than 2 to 1. And 7 to 1 will be, looks like, the most energy released. Our most energy released color would be violet. I'm going to use just the first letter of the color. And our least energy released would be, looks like 2 to 1, that's red. Okay, then you can use that to help you fill in the ones in between. Going from 3 to 1, that would be our next highest after red, orange. So you get to fill in the rest of these colors of photons when they change from these different energy levels, if these are the colors that we're seeing for a particular atom. So that is light emission for electrons, and we will be doing that, like I said, in lab this week using the flame test.